I've talked to him about your fit.
Okay, I'm gonna start sharing my screen now then. Oops. Okay. Oh my God. Okay, so on the left here, this is like the rocket I made when I was just like playing around. So this is basically what we're gonna be making. Let's see. Okay, so I'm just gonna go ahead and like get started, assuming everyone's will be downloaded as soon as possible. So just like follow along while I do it on my own computer. So the first thing, once you open it, you should see this. And the first thing you're gonna do is add a nose cone. So when you click nose cone, you get all these options. I'm gonna be clicking select preset and then from database, and that lets you choose like a already defined like nose cone. So I recommend using this Estes PNC 50YR. It's just a like small plastic nose cone, but you guys can really pick whichever one you want or make your own. So once I hit OK, then oh wait, there we go. So once you click either preset or whichever one you want to choose, just take note of this base diameter. So mine says 2.48 centimeters, and that's this length right here. So that number is going to need to match up to your body tube. So you can change it if you want, and then see how like I can make mine like a little longer. And then you can also play around with like basically all the materials in here. So like I'm gonna keep mine as this basic. Oops. Yeah. Okay. I'm gonna keep mine as this one, and then I'll click close. And so then next, you're gonna pick a body tube. So when you click body tube, you should check. OpenRocket should automatically match up this outer diameter with the base diameter from your nose cone so that they fit together. But you just want to check and make sure that those are the same. And then again, you can play around with the material. So if you were actually, because like right now we're just making like just an example rocket to get used to the program. But if you're trying to model a rocket that you've actually made, you want to like in ISS we use blue tube a lot, so you can change the material there, and then you'll see it'll affect your like stability, center of gravity, center of pressure. So right now, I mean, obviously, like this is unstable because there's nothing on it, but change it if you want. You can also pick the paint if you're really trying to like replicate a rocket that you have in front of you. So now I'm just gonna click close with this basic body tube. And then we're gonna do, sorry, so like, does everyone have, is everyone like up to this like step? No questions so far? Okay, so now we're gonna do fins and the launch lug. So in order to do this, you have to select your body tube, and you'll see all these options are now available. So then you'll choose what shape of fins. Again, like you guys are like design your own, so you don't have to follow exactly what I do. There's the trapezoidal ones. Oops. All right. So Nathan, you just entered. Do you have OpenRocket installed, open, ready to go? I can't really see like the chat when I'm on here.
Oh, yes, I do.
Okay, cool. So yeah, all we've done is add like a basic nose cone, a basic body tube. It's like up to you what you want to do and see how they work. But so yeah, make sure body tube is selected in order to see all these things. So I'm gonna click trapezoidal. I recommend that you don't click the freeform ones right now because then you're like gonna be playing around trying to make them. But if I click trapezoidal, you can pick the number of fins. So like obviously 3 and 4 is like normal. It does let you like add however many you want. Obviously 8 fins is like probably not a good design move. So I'm gonna stick to 3. And again with the component material, I'll change mine to, where is it? Oops. I'm gonna change mine to balsa. And then now that you've like clicked on whatever shape fins you want. Oh, what's up? So you can play around with these, like all these measurements and values.
Open a window.
You're fine.
Okay, so the root cord is going to be the length that touches the actual body tube, so this part right here. So if you play around with that, you can see how it changes the design. And then tip cord is the length opposite to that. So if I change it to like 4 and 1 centimeter, and then obviously like I'd want them angled down a little more. So if I increase the sweep angle, you can see the fins move like that. So you can play around and choose however you want. Now like my stability is positive. I'm getting more like real values. So I'm just gonna leave mine this. Let's see. So now, once you've like finished adding your fins, we can do the launch lug. So you have to make sure the body tube is selected again, and then over in the top right here is a section launch lug. So, okay, that's like obviously like very huge right now. So I'm going to make mine, well, I'm gonna change my outer diameter to inches and then make it, oops, not that, 0.125 because that's like an eighth of an inch, and then change, oh my gosh, okay, change the thickness. So oh, now mine is, okay, so these are the values I have for mine right now. That like looks like a pretty like normal size. It doesn't really matter as much what material this is. And then you're gonna click, once you have something, you like click close. But then we want to check and make sure our launch lug is in the right spot. So if you go to this view type and click the drop down, we're going to change the view from side view to back view. And so now you're looking like as if you were like holding the rocket up, looking underneath. And you can see the launch lug is in line with the fin, which is not going to work. So then you're going to click back in this menu and double click on the launch lug that you've already created. And to fix that, all you have to do is change the radial position. So now it doesn't really matter what it is, as long as it's out of the way of your fins, you're good. And then you can click close. And then we'll change back to the side view before we move on so we can still see our rocket. All right, says everyone good so far. Now we're gonna like add the inner components. So if you click on your body tube again, we're going to first select our inner tube. And the inner tube is going to be like what holds your motor in. So it's kind of big. We'll, I guess, oops. I'm just gonna play around with like Oh my gosh. Oops. Sorry, see, now I'm just like playing around with the numbers. I'm looking at how it's changing my rocket. Oops, I've changed my body tube length. Okay, so once you've selected this, again, I'm not going to change my material for this because I don't think it really matters. You can also, again, on this one, select presets. So it's one preset that I think is good is, again, Estes and then 3085. So if I select that, did it change? Oh my goodness. I'm not sure why my rocket is like changing so weirdly. I know I've got to get this back to normal. Sorry everyone, I've messed up my rocket already. Ah. All right, so this is what I was like saying before. Now I have to check my nose cone. Okay. We're back on track there. Okay, so you should all probably have a motor mount now, but make sure you click, when you double click on your inner tube, you have all these options up top. So we're gonna click on motor and then select this component is a motor mount. And then you can adjust the overhang. So as you can see, like, oh my goodness. Wait. Oh. Okay, my OpenRocket is being a little funny, but you can select like a 1 centimeter overhang, and then close that. And now we have to add a centering ring. So again, you need to click on your body tube in order to see that option, and it's right here. Let's see what's a good size. So right now it's like completely at the bottom. If you see over here, it says position relative to bottom of parent component, which means it's at the bottom of the body tube. And then you can move it back and forth just using these. So it should be like in the around the middle of your inner tube. So where I have mine is like pretty good. And then you can also play around with like the thickness if you wanted it. Again, material doesn't like really matter. So I'm gonna leave mine like that. All right, so now you should all have like a rocket that has like at least these components. It'll probably look a little different because, well, I just messed mine up a little. But now we can add a parachute because your rocket should definitely have a parachute. Again, that's something that you need to click on your body tube for. And if I click parachute here, again, you can click on whatever parachute you want. Its diameter should be about 30 centimeters or 12 inches. And then you can click on this packed length and packed diameter to kind of like basically like squeeze it into your rocket more. So it's not like just touching the entire sides. And then you want to move it closer into the middle of your rocket. And you can notice like that is going to change your center of gravity as you move like the mass of the distribution of your rocket. So again, you can change the material of the actual parachute, so silk, and that will usually change like your center of gravity and whatnot too. So you can keep it at like nylon. There aren't too many options, but if you're designing like based off of like a real rocket that you're trying to check out data for, you want to make sure that you're picking the right things. So we can click close, and then the shock cord is what's actually going to connect like the body tube and the nose cone. So again, if you select your body tube, you'll see the shock cord option, and you can select that. And that I'm also, oh dear, sorry. So I'm also going to move my shock cord to be around the same spot that my parachute is in, and then also make the pack diameter a little smaller. So as long as it's in the like same approximate spot as the parachute, you should be good. And at this point, hopefully you haven't had as many like mistakes as me, but your center of gravity should be in front of your center of pressure. So like mine is up here and the center of pressure is back there. And the bigger distance you have between them, the more stable your rocket is going to be. And so now that we've added all these components, we need to actually add a motor. So now at the top here, there's rocket design and then motors and configuration. So we can click on that. And you can click new configuration. And then in this inner tube spot, select motor. And so for my rocket, I'm going to be picking, again, an Estes one. I think using a B or a C engine. So like I can select Estes C5 and click OK. And then you can see it's added in. So right now my inner tube doesn't exactly line up. So I could go back and change that. You can also choose a couple different motors, because then when we get into the actual like flight simulations, you can play around and see which one performed better. So let me try and I'll click a B6 one now and see how that works out. And they probably already have like an ejection charge delay of some value. You can just leave it at that for now. So now I have two motor configurations. And then now you'll see at the bottom here, once you've selected motors, you'll get like a prediction for the apogee, which is the highest point in its altitude it'll reach, and then its max velocity and its max acceleration. So you can see how it changes. The C motor is like more powerful than the B one. So when I have my C motor in place, my apogee is predicted to be 312 meters, whereas the B is only 181 meters. So that's something to play around with, pick more powerful engines and see how they perform. So now you should have some sort of like normal looking rocket. I think mine looks a little funny, but you can go over here to flight simulations. And this is like probably the best part about OpenRocket, is that once you've designed this rocket, you get to look at how it would actually perform. So I can click new simulation, or I can click on the motors I've already selected and click run simulations. Oops, what's this? Okay, now I'm having issues running my simulation there, so there's something like wrong with my rocket. But I can still take a look at it, I think. So if I click plot and export and then click plot, I can still, even though there was like some error, probably because I was messing around with the size of it, you can take a look, and these plots show, so when the motor was ignited, when it burned out, and then look at it. So the red line is altitude, and you can see like how it performs. You want to look out for like when the parachute is deployed versus like when your rocket reached apogee, because obviously you don't want to look at the simulation and see that your rocket reached apogee and then started to fall a bunch before your parachute was deployed. So then that was for one of the motors. And then you can do the same thing if you have multiple configurations and take a look and compare those. And then you can export the data that these simulations took in and compare how they performed. This was my other rocket that I made. It's like slightly different. Like my inner tube had an overhang here. It's a little shorter, and I chose a different motor. So like this simulation like went through perfectly, and I can look at all the data collected here. So that was just like very brief, like how like you can play around with OpenRocket. Does anyone have questions from that? I wish I could see the chat. I don't know how to. If you have any questions, so basically like, I'm sure that if you guys are in aerospace, you'll use OpenRocket and like 8100. We also use it in the class I'm potentially teaching next semester. And you can use it in your tech projects to actually like mimic the rocket that you're building. So you can see if there's anything that needs to change before you finalize your design. So like I said, this is going to be like a brief just introduction. Is there a batch mode of OpenRocket? I don't actually know. I don't really use OpenRocket enough, so I'm not sure, but that sounds like something someone has probably tried to play around with in the past. So sorry, I can't give you a straight answer. You can Google that. We don't really do that with OpenRocket in ISS ever, so I haven't had the chance to take a look at that. I will be doing a Python tutorial in the next coming weeks, so I can take a look at that before and see if I can incorporate OpenRocket and Python into one tutorial, if I figure that out.
Do you know where we can download the OpenRocket file for this year's IREC rocket by chance?
I'm not sure where Angel has put it, but it's probably in the Teams. I guess I could look right now if I pause share.
I'll hop in and look.
What's that?
Oh, I was just saying I'll look in like Slack and Teams and see if they've posted it or posted where you can get it.
I would guess that it's in the Teams because in the past 2 years, like we've really started to use Teams a lot more for tech projects. So it's definitely in there somewhere. It might be in one of the old like ISS 2019 to 2020 teams. But also if you just ask Angel in the Slack, she'll definitely be able to point you in the right direction. Because I have not personally looked at that. Yeah, sorry, like not super interesting. OpenRocket is pretty easy to like pick up. You know, it's pretty like easy to understand how to do it. And of course I didn't go over like every component. Like I didn't add, because I just made a really basic one. You can still add couplers, bulkheads, engine blocks, and everything they might need for like a more realistic rocket. Basically the one I just designed is kind of like a really small like rocket from like a kit. And then like it can be fun to just like play around, like adding like freeform fins. And then if you play around with it and just try and like work to better your rocket's performance. You'll get a better idea of how components work together, how your center of gravity affects your stability, and how fast it's going to go. So do you guys have any other questions? I know there's not much to ask about OpenRocket, really. It's pretty self-explanatory. For those of you who are freshmen in aerospace, have you been using OpenRocket in AE100 at all? Okay, well, if there are no more questions, then I'm gonna make you guys stay on this. I figured this tutorial would be short. I will be doing more in-depth tutorials of like Python and MATLAB in the future. Those I definitely know way more about. I've had 2 software internships in the past, so those should be much better tutorials. And then you guys have probably already seen me like message about this a bunch in Slack, but if you have any other suggestions for tutorials, feel free to keep filling out my form. I got a lot for Python and MATLAB, so I'm definitely going to be doing those. I'm also probably going to do one on GMAT, if any of you know what that is. It's a NASA tool, GMAT, General Mission Analysis tool. And that one I've used in my later aerospace classes. And you can actually plot like a satellite and watch it, how it performs when it's orbiting Earth and whatnot. So let me know if you guys have any other suggestions or any other questions about OpenRocket.
I think I'm good. Thank you a lot. That helped a lot.
You're welcome. I know OpenRocket is not super difficult, but
yeah, I still really appreciate it.
Yeah, so I'll be doing better tutorials in the future. This was also kind of my test one because I figured I'd pick the easiest thing to do the first tutorial on, but I will be talking about how I've used Python and MATLAB within my aerospace classes and my research and my internships. So look out for those. They probably won't be for another couple weeks, but I recommend going to those ones too. Even if you're not interested in coding, it will still be helpful. All
Okay, well, I'm gonna head out. Thank you.
right, thank you guys all for coming. Have a good rest of your night.